LRU cache. What is this? Let's figure out. Let's get started. Well, design and implement a data structure for least recent use cache. It should support the following operations: get and put. Now, GetKey will get the key value of it. Notice that always be positive. It will get the value of the key if key exists in the cache. Otherwise, return -1. Set or insert the value if the key is not already present. And when the cache reaches capacity, it should invalidate the least recent use item before inserting a new item. So right now, right off the bat, what I'm thinking right now is using probably a linked list, a double linked list, or AKA DAC, to build this data structure. The cache is initialized with the positive capacity. Okay, so could you do both operations in a constant time complexity? So with a DAC, let's take a look at an example. So the capacity here is 2, and we have put 1 1. So we put key 1 value 1 to the cache, and then we'll put 2, and then get 1. Of course, 1 gets updated in terms of the how do you call least recent use expiration, something like that. But anyways, okay, let's call it freshness of the data. So 3s, and then we put 3. But now we have 1, 2, 3, which exceeds the largest capacity of the cache. So we need to evict the least recently used key. So we'll evict key 2. Oh, this is not. Yes, evict key 2. And then we'll get 2 that is not found, and we put 4, get 1, 3, 4, 1. It's only not there because it has been evicted. Okay. So they want us to do a constant time complexity. If we do a DAC, then now inserting get a key. Putting a key is gonna be easy. If we just put a key, well, if we use a DAC, then every time we get a key, it will take O(n) time, right? O(n) time to get to access a node in the DAC. Now, and if we put a key, first of all, if we're putting an existing key, then we also have to go through the DAC again to see if the key has already existed in the DAC, which takes a log n, a big over n. And then you will put this whatever new node at the end. So the time complexity using a DAC is big over n for both. For worst case, big over n for both situations. And so now what we can do is we can create a map to kind of keep track of the we'll say the address, or another way, the locations of the nodes. So we create a map whose key is going to be just the key of the nodes, and the values of the map would be the actual address of the nodes. So all right. So and in this case, then get will be constant time because accessing a node in the map will be constant, and then we just need to move that node to the end of the DAC. Okay. All right. So but unfortunately, I don't think we can use existing DAC API Let me think. Can we use existing deck API? I have a hunch that we can't. Because stack, you have to plug last, remove first, pick last, add last, offer last. So there's no remove the occurrence of the specific object from this deck, but it's comparing remove first occurrence of the specific element from the stack equals, so it's comparing value. So let me see if we create a map and then we keep track of the key and the object and the value. Key and value. So can we use this? You will keep track of the first occurrence. We'll keep track of the first occurrence of that. So let me think if we can use the existing API without doing this. Equivalent. This method is equivalent to remove first occurrence. If we are comparing equals use reference address comparison, content comparison. Equals is content comparison. So it's actually comparing content. Okay. Check if both point to the same memory location. Where okay. So what about? How about creating a key? How about using a hash map to? I want to take a look at the Java API. Linked list. Add last. Get last. Now there's another option is that okay. We remove this. Let me see. Remove, and then we'll add it to the end. Remove, add it to the end. There's no circumstance that we will have to. Okay. But the problem is it's comparing the content. So my concern. It's interesting. What if this object has two values? What if this object has two values? And how does it compare? How does it compare to compiler? Does it go through every? Yes. Fuck. Should have been familiar with this. I want to make sure that when we're doing equal to, it's comparing the key and value. And to be honest, we only need key, right? Because key, I assume that key here is, since it's a key and it's going to be unique. And if we have a deck that keeps track of the key, right? Also the value. Now the problem is that I don't know if remove since it's comparing content, then I don't think it's removing by address. So I feel like it's going through. I feel like it's going through the linked list to remove that object. So essentially, it will be the same. So here, okay. So here it's still not a good idea to use the existing DAC API. So the DAC library. So we do have to create our own DAC double linked list, aka DAC. Okay, so say we have a private class, and let's call it node, shall we? And so here we will need to create. First of all, we need to have. Sorry, this is not. So we need to have a node, which is called head, and we will need to have a tail, right? Well, sorry. So previous, we're pointing to previous, and next. Oh, at the same time, we also need to have a key, and we need to have a value. Okay, so and don't forget that we also need to have key, value. Okay, and this key equal to key, and this value equal to value. Okay, so now this is done. This is how we will create the node. And when we reach the capacity, well, of course, we need to have another private global variable. This is called capacity. And we'll have this, the capacity is equal to capacity. Okay, now what we need to do here is also don't forget, like we said, we also need another map. So integer and node. So we have a map here, and we will create this map is equal to new hash map integer node. Okay, so now we are done. What we need to do next step is to create a we need to instantiate a head and tail, so then we can keep track of the node. We can keep track of the linked list from either from head and from tail. Okay. So Okay. All right. So now we have initiated the all these variables. The next step is to get to get. Okay. So for get. So for get, what we need to do is to check the time first, and then so let's think about put, get, and put. What we need to put, and what we need to implement in general. So it seems like for get and put, no matter what we need to do, we always need to update the tail. We often need to update the node to the tail, push it, because when we get it or if we put it, we are using this node. So if we can, well, I think we should. Oh, I also need to. No, it's not here. It's here. Head is equal to null, and node tail is equal to. Okay. What did my alarm go off? Okay, so I think here we need to write a function. Say, I'll implement this function later. But for now, is I move to tail, and then we'll put in node. So this one will move this node to the tail. But for now, I'll just assume it's been implemented. And for get, so first of all, we need to see if we need so first of all, for get, we need to see if this exists or not. So we need to see if this one exists or not. If not, then we'll return -1, right? And if it does exist, what if it does exist? So if it does exist, then we will access the node. We'll access this node. If it does exist, we'll access this node in the linked list via the map, and then move it to the end. Okay, so first of all, if contains key, if it doesn't contain key, then we'll just return -1, right? Okay, so if it doesn't contain this key, then we'll return -1. If it does, then we'll get key gets. Okay. We'll get this node. This is the position of the node, and then we need to move it to tail. Well, first of all, we need to move to tail, means that we need to plug it up first and then move it to the end. But I guess we can do this in this function. So I'll say move to tail, cr, and okay, so for put, first of all, we need to make sure that if exists exceeds the capacity. But most importantly, we need to move this, update this. So when it turns to move to tell, we already know that this node exists, right? But for put, there's some new node. There's some new node that is being put. So if we move to tell, well, if it's new, then we obviously know that this will be attached to the end of the. So if it's brand new, then we obviously know that this will be attached to the end of the tail, end of the doubly linked list, and we'll remove the we'll remove the head, well, if it doesn't, if it does exist to the map, then what we need to do is that now, if it does exist in the map, then what we will do is move update the value of this one. Wait, so I feel like we can reuse this, right? So if get key is not equal to -1, I have a hunch that I won't be able to finish this. Okay, so if GetKey is not equal to -1, which means that it has already exist. However, now this is what we need to do, right? If GetKey is equal to -1, which means it doesn't exist, then well, this is pretty much the same as this one. So if it doesn't exist, we know what to do. Now if it does exist, oh wait, hold on. This is a little bit my twisting. Well, I don't need to else here because I'm going to return at the end here because this is two different scenarios. So first of all, let's think of it. If GetKey does not exist, then let's create a new node. Node is new node is equal to new node key value. Okay, and we'll push this to the end of the. We'll push this to the end of the deck. Now, first of all, we need to see if. Why am I doing this capacity is equal to this? This should be current capacity. Okay, and the current capacity will be equal to 0. Okay, so current capacity will be equal to 0. If current capacity is equal to capacity, then we need to remove the head. So let me think. So head. We just need to know the head, and then the next of head dot next dot next. Because if it's equal to 1, or if it's equal to, if it's reach a capacity, then which means that obviously there are some nodes in the deck, but we can discuss the edge cases later. Next, head.next. Okay, so what we need to do is, first of all, head next.prev is not head next.prev is not that thing anymore. And then head.next is equal to next head. So head.next, this will be assigned to next, and then next.prev will be assigned to head, will be assigned to next.prev. So this is done, and so this is got written off, and most importantly, don't forget to remove map.get dot remove next no. So first of all, we need to do is remove head.next dot key. Okay, so we have removed the head of the linked list, and we're running out of time. Fuck! Hashtag demonetized or unmonetized. Okay. And then we just need to append this to the tail, right? Okay. So I feel like this essentially is doing the same thing, right? So let me do move to tail, and then let's do new node, move to tail. Okay. And then we can now another thing is that we'll need to update put key value. Okay. Return. Okay. Move to tail, and then we'll map.put key value. Okay. So So I was thinking if we can refactor this, but let's go move forward. So if it doesn't, then it means that this node X exists and doubly linked list. And what we need to do is that we need to but since we call GetKey is not equal to 0, so this has already been moved to the tail. And now what we need to do here is we pretty much need to do the same. God damn it! All right, I'll reset it. Start. How many? I would like to see how many 30 minutes I spent on this question. So, and then this is basically the same thing, which makes me think that I'm doing. I can just do this regardless in the beginning, right? Well, yeah, I can just do this in the beginning, right? So I can refactor this a little bit. Now, for example, I can do this. I can do this in the beginning, and no, you can't, because you are checking if this exists. So it's kind of complicated. So because you're using if map contains the key or not. If you did it directly, it's gonna cause issues. So what if it doesn't contain key? I'm trying to see if I can refactor this a little bit. So if GetKey doesn't, if it does exist, then then things will be a little bit simpler. We just need to put okay. So if GetKey is not equal to -1, and now if we get it, we've got it, and this one has been moved to the tail, and then we just update the map value. And if not, then it's a new value. Okay, if not, it's a new value, and then if it reaches this, then we will update. Or if it reaches the maximum capacity, we'll update the node, and then we'll move the new node to the end of the. So I feel like, and then we need to, don't forget to do this. Okay. All right. Okay. So, what about move to? I feel like my usage of move to tail is a little bit contradicting, because here I'm assuming current exists, and here move to tail. So I think the safest way would be just for this private function, just assume that the new node. It's a node, and we're just inserting, or it's just simply inserting. We are not removing it. We're not removing it. So which means that we do need to implement the current here a little bit. So I mean to take it out of the linked list. So first of all, we need to know the previous node, and okay. So first of all, we'll need the previous node is crr.prev, and node next node oh wait, sorry, I got a phone call. Okay, let's continue where we left off. Sorry, there's someone just called me. It was actually from a recruiter. Huh. What company? I can't tell you. Okay, so next. Okay, so get key, and then if it doesn't contain key, we'll return, and then we'll pop up this node. So we will have. Let me continue the timer. So that was my second 30-minute counter. Okay, so we'll have previous node is equal to this, and then we have current node is equal to next. Okay, so we have saved the address of these two nodes, and what we need to do here is that previous the previous so the previous node, the next node of the next pointer of previous node will be pointed to the next node. And okay, so here we do. So the previous node dot next will be equal to next node, and the next node dot previous will be equal to previous. Okay, all right. So, and then we need to move it to tail, and for tail, it's pretty much the same thing. We already have a tail, and what we need to do is to get the previous node. Okay, and so now we have the previous node, and we need to insert the new node after the previous node. So this will be previous dot next is equal to node, and then node dot prev equal to prev. Okay, and let's call it previous node, so that not to confuse the other naming. So we'll have node previous node dot next, and then previous node equal to node dot prev, and then node dot next will be tail, and then tail dot prev will be node. Okay, so that's the end, and maybe we can go through this. Let me see if this compiles. Compilation error. It cannot be converted to line 48. Okay. Runtime error, so I feel like I must be messed up somewhere around. Head.next equal to tail, and then tail head.next. Do you really need a head? So map. So first of all, what is, so you have put. You put 1 If GetKey map dot contains key, if doesn't contains key, I'm sorry. If it doesn't contain key, okay, if it doesn't contain key, I'll return 1. Then of course it will be -1, right? And this will be inserted as new node. Will be created a new node, and this is a little bit confusing. Okay. So if it's equal to, so right now the current capacity, oh, after you put it, you need to so if it doesn't exist, and then you need to add and then if it's not, then you need to add current capacity plus plus. So you have a new node, and if it doesn't reach the capacity, it will increase 1, and move to tail, new node. New node will be added to tail, right? Okay, so tail.prev is add, and prev.next is equal to node, and node.prev will be previous node, okay? And node.next will be tail, and then tail.prev will be node. It looks good to me. And then we'll put it a new node, which is key and the key value. So I don't understand why it's right. One, two, 1, 1, 2, 2, and then when we reach 1, when we try to get 1, we run into a runtime error. Private class. Is it because that this has to be public? Runtime error. I mean, ideally we should add a get. Is it because of? I mean, we should be able to access this, right? Because if we don't specify it, it's protected. But protected is accessible to class. I mean, unless okay, let's see the. Okay. I'm not sure why it's not getting. So get, if you call get, now it does contain. It does contain. I wish you can run debug. So it doesn't even reach here. So map.getKey assigned to current. Okay. We get this node. Current.prev. Son of a bitch. Current.prev is equal to previous node. So I save the current next node and previous node and next node. And then I assign next node to previous node dot next and previous node dot. So it should be right. It should be right. I don't understand why it's not. Why it's having is this something wrong, guys? Is it because something wrong? Okay, so here it got through here, and then what about this? Why does it have a runtime error? So here is correct too. I don't understand. So it's this line. Next node, previous node assigned to next node. So at 1122, and when we try to get 1, I ran into a runtime error. Interesting. Why? I don't understand why. Fuck. So it's this line that there's something wrong. Is it because I'm trying to assign current.prev? So previous dot next is equal to next. I don't see anything wrong with that. This is unless I can't even refer. So previous node dot key So this should be -1, right? And this should be it doesn't even shoot. It's because this is a private class. What's causing the runtime error? So when I try to access previous node, runtime error could be previous node. It just oh wait, hold up. So put is called first. It doesn't exist. God damn it. So put, if it doesn't exist, GetKey doesn't exist, then we just put, wait, we didn't even insert. There's something wrong. We didn't even insert this. We didn't even. We didn't even insert this key here. Wait. We're inserting a key here. Oh fuck! My brain's not working. So 1122, and they get key. Now the problem is that when we're trying to get key, it's returning a runtime error. It's not helpful at all. It just tells you it's a runtime error. Okay, so god damn it! Oh, so you okay. So when we put let's go through the examples first. So when we put we try to put 1 and 1, right? So we have 1 1 and 1 1 here. Okay, so we have 1 1 and GetKey. We call GetKey. It doesn't contain return -1. It's equal to -1. So we'll jump right here, and we will have new node. Okay, new node is being created, and now not current, but it's no current capacity. So current capacity could increase 1, and then move to tail. Okay, so tail.prev is equal to this prev now. Okay, and node dot and then node will be assigned to prev dot next. Okay, and Okay, and prev.node will be assigned to node.prev. What the fuck is this? Is it a pre? Okay, pre-node was assigned to node.prev, and node next is equal to tell. No, okay. So this one looks right, but I don't understand. So and then put okay, and then you put wait. If this doesn't exist, hey, hold on. Then we should just put. We should update this, right? Instead of putting new node. It's just fucked up. So if it's not equal to 1, then we should update this. Okay, and then here, but this one shouldn't matter. We have problem when we're trying to get it. God damn it! So when we're trying to get it, if it doesn't contain, we'll just return 1. No, this one does contain, and map.getKey is here, and current previous. So what will happen if I try to just get? It doesn't even get this. It doesn't even get this. It doesn't even get the previous node. I don't know why. But here, it's not even running here. Okay, what about? Is it because of this? Because this is a well. Son of a bitch. Okay, so this is not. I don't know. So when you map.get. I want to figure this out. So map.getKey is not reading. I don't know what kind of I'm not sure what kind of runtime error is that. Okay, I guess I just have to copy this and open up Eclipse. My hunch is that there's something related to, must be something related to address. So if I run this, okay, this is good. And then what if I, so we have obj dot put 1, 1, and then we have obj dot put 2, 2, and then try to obj dot get get 1. And we have system out dot print. What happened? Exception in method. Solution 43. Okay, so we have a problem when we try to access I'm hell confused. Null pointer exception, which means that I didn't even see this. Null pointer exception, which means that the previous node does not even exist. Does not even exist. Then 1, 1, 1, negative 1, 2, 2, 1. So when you add one previous node, okay, and when you get it, when we try to get it, previous node, okay, previous node is not exist. Okay. What the hell? Why? Tell me why? Why? that they have to be like this? Tell me why. Oh, wait. Why are you putting new? Huh. What the heck? You can just put new node, bitch. Oh, okay. All right. I don't even know why I put new node here. It should be node. Sorry. New node. It's really hard to talk while you speak. Okay, looks about right. Maybe I should get rid of the print statements. Wow, I spent 1 hour and 8 minutes on this. Alright, submit it. Accept it. Okay, perfect. So my logic was correct, but I don't know why I did this new. It's probably because when I coded, I said I put a new node and then I create a new node, literally, but I didn't put this new node into the parameter. It's really hard to code when you talk, so I feel like next time what I should do is I should come up with yes, talk about your general approach first and then start coding. And when you're coding, don't try to talk while code. You talk first and then you kind of leave it a little bit of silence when you code so that you can focus on your actual code better instead of forking your thought process into two threads, which is not as efficient, right? So next time, let me try this. When I code this small code chiplet, snippet, I would say my approach first and code, or code a little bit first and then say what I did here, instead of doing this at the same time. All right, this one took me 1 hour and 8 minutes. Anyways, glad that I solved it, and thank you for watching if you've been sticking around this whole time, and thanks for watching. I'll see you next time.